Hello everyone, welcome back. In this video, you will learn how to test for homoscedasticity in SPSS using scatterplots of residuals. Also, you will learn how to interpret the result. This is one of the key assumptions in linear regression analysis, and as a matter of fact, violating this particular assumption can lead to unstable conclusions. Before we dive in, please don't forget to subscribe to our channel, hit the bell notification icon. Also, follow us on all our social media, Twitter, Instagram, Facebook, TikTok for more research and statistical tips. Now, what is homoscedasticity? It simply means that the residual or errors in a regression model have constant variance across all levels of the independent variable. That is, the variance of x1 is not different from the variance of x2, is not also different from the variance of s3, s4, and so on and so forth. Don't forget, y is dependent variable, y, x are independent variable. When this assumption is violated, you must know that your model is suffering from the problem of heteroscedasticity, and in that case, your standard error may be biased, and also your p-value could be misleading. Your p-value may indicate significance. It may be less than 5%, whereas it should be greater than 5%. Also, it will affect your standard error. So there is a need for you to address this particular problem before proceeding with your analysis. Now, the question may be, how do I interpret the scatter plot? Of course, this particular scatter plot is the same thing with the one that is used for outlier and others, but the method of computing it is different from that of outlier. SPSS will generate an output with a scatter plot of standard residuals versus predicted value. So what you need to do is to look for a random or evenly spread cloud of points. So the way you look at it is not that different from the way you look at your outlier scatter plot. You must just ensure that the points spread and it doesn't take any form. It doesn't take a funnel form. It doesn't look like it doesn't look like a cluster of points, and it must not also look like a curve pattern. So you have to ensure that the points spread randomly. So when you have such situation, then you can say that the residuals have constant variance, which satisfy the homoscedasticity assumption. So after checking for linearity test, normality test, the next important assumption which you must check for is this particular one. And in case you don't know how to check for linearity as well as normality tests in SPSS, kindly check this particular playlist or the description of this video. You will see the link of those videos. So now, to interpret your results, you must look for all these things. First is that if you notice that your graph it looks like a funnel, that is, points spread out as value increases or decreases, something like this curve. This is what I mean by funnel. This, something like this. So in that case, you need to address the heteroscedasticity problem. When the graphs looks like this or the scatter plots look like this, then there is a problem with your data set. Then there is a need for you to correct it. Another thing you need to look at is when the scatter plots looks like a curve pattern, something like this. You can see the way the points spread. Though the points spread, but the pattern is like a curve. Look at it from here. If you join all these points together, or you fit the line, or you fit the curve. If you fit the curve, and it looks like this. I will certainly show you how to fit the curve in SPSS. If you fit the curve and it looks like this, then there is a problem with your data. And the third point is cluster of points. If the points clusters like this, something like this particular graph here, then there is a problem with your data set. So in short, when you check the scatter plots and you notice that the points are like a funnel shape, takes the form of a funnel, a curve pattern, or cluster of points, then there is a problem of heteroscedasticity. For you to satisfy your scatter plots, you must ensure that the points are evenly spread. Now, the question you may want to ask is, how do I correct this particular problem? To correct it, you need to either transform your variables or you use robust regression techniques if this assumption is violated. Also, you can use a non-parametric techniques of analysis. So you either transform your variable, you use a robust regression techniques that account for this heteroscedasticity problem, or you make use of non-parametric test, which is also a robust regression techniques. Now let me also tell you something that is very, very important. You can't rely on this particular graphical method approach alone. There are some other statistical tests that you need to check, or that you need to look out for before you make your conclusion. Also, you can combine the scatter plots with this test. The first one is a Bagan test, and the second one is white test. I will do another video on each of these tests, how to run it, the assumption, the decision rule, the hypothesis, as well as how to interpret the results. So you can come back to this channel and check the video. But now let me take you to SPSS and show you how to run or to check for normality test. Please take notes, when you want to do this test, you need to identify your dependent and independent variable. So in this data set, we want to look at the impact of income on weights. We want to check whether if income increases, weight also increases, or if there is a positive or a negative relationship between income and weight. And we are also going to use age as a control variable, as well as one other variable, maybe employment status or category as control variables. So now to do this particular analysis, or to check for homoscedasticity, you go to analyze. From analyze, you select regression. Then from here you select linear regression. Now the first thing you need to do is to identify your dependent variable. The dependent variable is weight, so you click on weight and you move it here. Next is to identify your independent variables. The major variable in our model is current salary, which is income. Then we want to use age as a control variable, as well as employment categories. Now we have three independent variables, that is x1, s2, s3, and dependent variable. You should take note that the dependent variable is continuous, and we also have one independent variable that is continuous, because one of the assumptions of our regression model is that the dependent variable must be continuous, and one of the independent variable must also be a continuous data. So we have satisfied that particular assumption. The next thing you need to do is to click on plots. You click on plots, and here we have two residuals here, the set spread as well as the set rest. Now the set spread, you move it to the x-axis. This particular one, you click on it and move it to the x-axis. Then the set residual, you move it to the y-axis. In case you need the histogram, you can check, as well as the normal probability plot. You can check these two options, but we don't need this because we have already done normality test. So on check, then you click continue. Once you do that, the next thing is to click OK. Now you have we have our outputs. Here we have the list of the variables, employment category, age, and current salaries. Those are the dependent and independent variables. Then this is the model summary. This is ANOVA. This is coefficients. You can see all the other variables are not significant, and this, yes, current salary and age, negative relationship with weight, while employment category, positive relationship. Although our focus is not that. Our focus is this plots. This is our focus, this particular scatter plots. Now if you look at it, you will see that the points spread randomly. Look at the condition here. Let me take you back to the SPSS. Look at it. Look for a random, evenly spread cloud of points. So if you look at it now, you can see that these points are evenly spread. There's no points at this edge, no points at this edge, no points at this edge. They are just evenly spread. Now if you click on it twice, you can see let's check the curve. Let's fit the curve. This is it. Then you fit the curve. Let's fit line. Yes, let's fit line as total. No, this one is not. Okay, I want to check this interpolation line. Okay, let's make use of that interpolation line. You can see the point is not like it's not clustered. It doesn't take a funnel shape, and it doesn't look like a curve pattern. Look at all these ones. Our point doesn't look like this curve pattern. It doesn't look like this cluster of points, and it doesn't look like a what? A funnel shape. So we can conclude based on this particular graph or this scatter plot that this particular model is not suffering from the problem of heteroscedasticity. In other words, the model is homoscedastic. So this particular model is fine, is perfect, and you can make use of a parametric approach. We can proceed with the interpretation of the regression analysis based on these results. But don't forget that I said you may need to combine this particular result with Bruce-Bagan or the White approach. So now let me quickly show you how to interpret this particular result. I've done the interpretation. I'll just read it out. But the summary is that the model is homoscedastic and parametric approach can be used for the analysis. That's just the summary of the result of this particular analysis. So look at it. Look at the interpretation here. This particular scatter plots appear homoscedastic. And why? First point is that homoscedasticity means that the residual have a constant variance across all levels of the predicted value independent variables, and you can see the points are evenly spread. In this plot, the points are randomly scattered. They are not clustered. The points do not look like a funnel shape, do not take a funnel shape, neither a curve pattern. Randomly scattered around the horizontal line. You can see this is the horizontal line, and they are what? They are randomly scattered up, down, and the spread of residuals does not increase or decrease noticeably as predicted value changes. You can see there's no one that either comes to the extreme here or here. So from here there's no significant outliers, nothing. There's no points that is here, no points here. Everything is around this part. All the points are around this particular horizontal line. There is no clear or funnel shape. I've showed you that curve pattern or systematic pattern, which would suggest heteroscedasticity. So in conclusion, the assumption of homoscedasticity appears to be met in this particular model, and once this particular assumption is satisfied, we can now use, or I can now use, parametric method. So now if you are doing your analysis and you are able to come up with this type of scatter plot, I can assure you that nobody will doubt the outcome of your study if you make use of a parametric approach. Thank you, and please don't forget to subscribe to our channel, like our video, and share it with your family and friends. In the next video, I will show you how to run a Bruce-Bagan approach as well as White approach in SPSS.